computer. And I need to get this. Okay, so let me share my screen. So my goal today is to do a couple of things. I want to, actually what I'm going to do is I just want to review. I want to make sure you're good to have this. So a few things that you're allowed to have on the review. You can have that unit circle that we did in class on there. If you have a photo of it on your phone, that's fine, but that's the only thing I want to see open on your phone. Or in paper. So it's your choice, okay? I'm not telling you which way is the right way, the wrong way. I'm just letting you know that would be available. So I will, excuse me, I will finish the sine stuff, and I will also go over cosine. They're very much related. Basically, sine looks like this, and cosine looks like this. And they're both related to the inner circle. It's very identical. So on Thursday or Friday, we will have that. We will finish up the sines and bring those notes back. And then we will also have the cosine that I will give you. And then I'll also give you the stuff for Monday, but I didn't really have a lot for today other than I just want to make sure we can review. And I want you all to interact with me a little bit. So I want to, if you write these problems down, or if you just kind of sit there and watch and you look at the notes later, let's say I know this is 8. So you can guarantee that this is a 60-degree angle, correct? So what's the hypotenuse going to be?
17.
17.
16.
16. You double it a little too much. So what is this side going to be?
8√3.
8√3. Very good. Is there anybody who would be stuck on that kind of problem? Andrew, I like the pink lights. Those are awesome. All right, what if we have this, and I give you that being 10? What do you know this to be? And how would I get to it? From here to here, I would have multiplied by √3. So what do I do from here to here?
$10 divided by √3?
Yeah, you're going to divide by √3. So it'll be 10 over √3. Rationalize it. When you rationalize it, and multiply both top and bottom by √3 and √3. So you get 10 √3. √3 times √3 is 9. Square root of 3 is 3. So this side is 10 √3. So what do you know about the hypotenuse in this case?
It's going to be 20√3 over 3.
Yeah, 20 √3 over 3. It's double the opposite side of the 30. Okay. What else you got? Any questions on either of those? Those are definitely two problems you would definitely see and you'd have to be able to work out. What if I had this? What if I knew that to be 12? What would this side right here have to be?
6√3?
6√3 is down here. So what's this side then have to be?
6.
6.
6, yeah. So it's the side opposite of the 30 is always half of the hypotenuse, and the side opposite of the 60 is always the square root of 3 times larger than the side of the opposite side of the 30. Okay. What about our 45, 45, 90? So if that's 45, you know that's 45. What if this is 7? What does this side got to be?
7.
7. What does this side have to be?
7 root 2.
7 root 2. Very good. What if I gave you this being 30 root 2? What do these sides are both the same, so what do they have to be?
30.
Yeah, just 30. Okay. Is there any questions about those? Feel okay? Can I move on? All right, so now I'm not going to make that a 30. I'm going to make this a theta, Greek letter theta, Greek letter t, lowercase t in the Greek alphabet. What if we knew this was 5, 12, 13? I want the sine of theta, the cosine of theta, and the tangent of theta. What's the sine of theta?
5/13.
5/13, yeah. So sine is opposite of our hypotenuse, or some old hippie. What is cosine of theta?
12/13.
12/13. So adjacent over hypotenuse, or caught another hippie. And then what is tangent?
5/12.
5/12. So tripping on acid. Good. And then the reciprocal of sine is cosecant. So what's the reciprocal then? What's the reciprocal?
13/5.
13/5. Excellent. What is the secant? Secant's the reciprocal of cosine. So what's that got to be?
13/12.
13/12.
Good. And cotangent is, what's the reciprocal of tangent? Ooh, fire truck. Or cop car. What's cotangent of theta?
12/5.
Okay. You'll see a problem very similar to that on the test. You feel comfortable with that? Okay, may I move on? All right, so I don't know why I drew that. I want to find the smallest positive angle between 0 . Okay, so that means that I'm trying to figure out where on the unit circle it's going to. So it's like, where do I wind up? Okay, I'm not coming off the x-axis on these ones. What I'm doing is I'm dealing with 360 degrees. So what if I had 1050 degrees? Does that go around the circle once? So what does 1050 look like? So basically it looks like this if I had drawn it. There's 360, 720, and then it stops here. How far would this have to be? Actually, how far is from here to here? What do you think?
330.
How much?
330.
Yeah. How did you get that? You're absolutely right. That's the correct answer. How do you know? What did you do?
I just estimated.
Estimated. I drew that well. So you're absolutely right. You're going to subtract 360, and that's still going to be a number that's larger than 360. So you subtract 360 a second time because it keeps going around the circle, and then you are left with 330 degrees. So that is the smallest positive coterminal angle. So the coterminal angle starts here and goes around the circle and where it would end. Okay. What if I had negative 540 degrees? So think about what that's doing. That's going this way, correct? So negative 540. If we add 360 to it, that's going to give me negative 180. But I want the angle to be between this. So negative 180 is the same as what? We're looking to go this way. What do you think? So if we went all the way around the circle once, so this took care of going this way. If I'm going this way, it's negative. So I'm going to come around and I'm going to end right back here. That's where I ended. So that's negative 180. So what's negative 180's positive counterpart? How far would it be from here to here then?
Positive 180.
Yeah, so positive 180 is, and you don't have to have the positive there. I just put it there so it fit in there. So that is the smallest positive angle that it refers to off of our unit circle. Okay, so smallest positive means you're going to say, I'm going to start here and I'm going to figure out how far it would have to go to get to between 0 and 360 degrees. Okay, now there's one thing different when they say, what is the reference angle? And this comes off of the x-axis. Okay, so if we had an angle like here, we're looking for theta to be here. So in order to get it in quadrant 2, you would go 180 minus your angle theta. Okay, but if this came around here and we're now in quadrant 3, and this is theta down here, that's going to be theta minus 180. Okay, and then the last one would be if it happened in quadrant 1, it's just itself. But if we came all the way around here, if we were trying to figure out what this angle theta here was, we would do 360 minus theta, or 360 minus our angle to get theta. And I guess that should have been 180 minus our angle to get theta. And this should have been our angle minus 180 to get theta. So I went backwards on those. And then if theta if it happens in quadrant 1, it's itself. Okay. All right. That takes care of the first 14 problems. So after that, we will want you to convert to degrees. So let's say we had 5 pi over 10. I know that's goofy. If I wanted to convert this to degrees, I'm going to multiply by 180 over pi. The pi's cancel nicely. See if you can reduce. 5, that goes in there twice. This 2 goes in there 90 times. So this would be a 90-degree angle. So the big thing to know on this is you take your radian times pi over 180 and reduce. Okay. Oops. Oh my gosh. Erase what I just said. It's 180 over pi. I'm sorry. And reduce. If we wanted to convert to a radian, so let's say we had 40 degrees and we wanted to make it a radian, I'm going to multiply that by pi over 180. So that becomes 40 pi over 180, reduce, which becomes 4 pi over 18, which that'll reduce to 2 pi over 9. So what to remember here is you take your degree times pi over 180 and reduce. But leave pi. Okay? All right. The 19 through 30 is you being able to recognize sine, cosine, and tangent when given some angle. So let's say I wanted to do the sine of, let's see, sine of pi thirds. So remember, we are looking for the y part. So if you're looking at your unit circle, there's going to be a point that's given. That point's x comma y. So it's sine, so I'm looking for the y component. So at pi thirds, which is, it's on your unit circle, what does that answer? What do you think?
Root 3 over 2.
Root 3 over 2? Cool, because that would have referred to the point as 1/2, or actually, yeah, that's right. It's a 60-degree angle. So we would have had the short and the long in that order. I look at the point, I look at the y value, because sine goes as the y, cosine goes with the x. So cosine, so it's always x comma y, which is alphabetical, and then cosine comma sine, which is also alphabetical. What if I had the cosine of pi? Cosine is the x value. So it is the cosine of pi.
Is it -1?
It is, good. And if you had found this on your unit circle, it falls over here, which is -1, 0. Because it's cosine, I look at the x value and it's done. Tangent's the only one that gets a little tricky because you have to figure out that you're doing y over x. So let's say we had tangent of 5 pi over 4. So you have to remember tangent is y over x. So what is 5 pi over 4 as a point? What is the point value? What'd you get for the point values on your unit circle?
Negative root 2 over 2, negative root 2 over 2.
Negative root 2 over 2, comma negative root 2 over 2. Agree? Because this basically takes place down here. It's the 45-degree angle down there. So I'm going to go y over x. So I'm going to get negative root 2 over 2 over negative root 2 over 2. Negative or negative is positive. Root 2 over 2 over root 2 over 2 makes it positive 1. Okay? All right. The last ones, they might give you in the directions that we're going between. So you have to know that this is quadrant 1 and 2. Because from here to here, this is 0. This is, oops, it's in quadrant 1. That's pi. So this up here has to be pi over 2. So this is in quadrant 1. So if I gave you the sine of 1/2, all right, I take it back. If I gave you sine theta equals 1/2, and you know it's in quadrant 1, which angle in radians, because you know it's radians because this has that. What angle in radians has a sine of 1/2? Remember, this is the y component. What do you think?
Pi over 6.
Pi over 6? What do you think, friends? Is that right? I like it. So does that make sense? So sine, so this is theta here. And this would have been root 3 over 2, comma 1/2. So I have my long x and my short y. That's the 1/2. Pi over 6 is 30 degrees, and that's totally the correct answer. What about if I had tangent theta equals root 3? So this is where you have to look. You're looking at your y over x. If you were to take your points, which value would have just a root 3 of an answer once you have reduced it? So if we go back and refer to this point right here, that would be 1/2 over root 3 over 2, which is 1/2 times the reciprocal. So that gives me 1 over root 3. Is 1 over root 3 the same thing as this? The answer is no. So then you have to look at the other one. That would have been root 3 over 2 over 1/2. Multiply both top and bottom by the reciprocal. And that gives me root 3. So that is our 60-degree angle, and our 60-degree angle, this should be pi over 3. You see how I did that one? Those are tougher. The tangents are the tougher ones. And it's just a matter of you understanding how to multiply by the reciprocal of the denominator. So still building on the exact same thing, what would you do if they wanted it between this? Which quadrant are you in? Is it 1? Is it 2? Is it 3? Or is it 4?
3.
Yeah, it's in 3. And things you have to know about 3 is you have a negative x and a negative y. Okay? So be cautious when you're doing those ones. But you might have, let's see. Yeah, that would work. What about if I had this quadrant here? Which quadrant is this one in? Or is it in multiple quadrants? So what if I knew I wanted cosine of theta to be negative 1/2? Cosine is which value, x or y?
X.
It's our x values, so we know we're looking at our x values. Which x values anywhere around our unit circle, so it happens in all 4 quadrants because this is listed all 4 quadrants. Which angles have negative 1/2 for an x value?
Two and three.
2 and 3. So being that we know that all students take calculus, it is definitely negative down here. What angle does that refer to in radians? There's 2 of them. What angles have a negative 1/2 as an x component? What do you think?
A 135 and 225.
Okay. What's the radian amounts of those?
3 pi over 4 and 5 pi over 4.
I like it. And how do we know the answer should be in radians? This here, it will tell us that it should be in radians. It actually will tell you on the test in radians, theta in radians. So here you're looking for that. So that, my friends, is basically the entire quiz. It's the front and the back. There is one bonus question. No, I'm not going to go over the bonus question. But that's what you have to do. Is there anything that we just did that you have questions about for me? We good? Let me double check what time we're out of here. Did you see anything you want to go over? All right, so this will not be on the quiz, but this is just kind of adding to it. When graphing the sine graph, which is sin, basically the main thing to realize about sine is sine starts at the midline and then hits a maximum, goes back to the midline, hits a minimum, goes back to the midline. So this is basically what our sine graph looks like. And it'll keep going. Okay. There are things that definitely stick out to when you're looking at the graph that we'll build upon a little bit more, but this is the main concept with it. And I know I had asked you to kind of maybe start on the homework, but I'm just curious if there was anything that was sitting on the homework that is not due today. Is there anything on the homework that's not due today that you looked at and you're like, whoa, dude? And again, I didn't finish the entire lesson, so I'm not expecting you to have this done. But I would say you should have started it a little bit. Is there anything on, I think it was on trig G. Was there anything that you were looking at on there that you're like, I'm not sure?
So for the equations, it's a sine bx plus c plus d,
Yeah,
right? Is that like the standard form or what?
yeah. So you're exactly right. So it's basically like this. Okay, the main thing I did here is this. So the A value is the amplitude. This is how high above or below the center line we go. A is negative if the sine graph starts out going downward. A is positive if the graph starts going upward. And then the B, when it's factored out like that, this B value is going to, whatever that B is how often graph happens between 0 and 2 pi or 0 and 360 degrees. Okay, so that's basically what you're looking at when you're doing the sine graph. The D value is the center line. It's the line that you go above and below. And then the C over B, we're not going to really hit. But that also that kind of deals with how it stretches it out horizontally, but we're not necessarily going to look at that. So is there anything off of any of that homework if you're looking at? I gave you a whole bunch. We haven't started really graphing it yet. But let's do one. This one is just off the cuff. Let's say I had y equals -3 sine of 4x plus 5. Okay, so this is doing an awful lot. This is how, if you could do it this way, you can nail it every time. My parent function looks like this. So this is 0. This is pi halves. This is pi. This is 3 pi over 2. This is 2 pi. Right now, this is a max, and this is a min. So there's things that we can go about on this problem and work out. So first thing I'm going to do is I'm going to say, okay, my center line is 5. So I'm going to label this in the vertical direction 5. Okay, this -3 means I'm going to go, I have an amplitude of absolute value of -3, which is equal to 3. But this negative is going to make it go down first. Okay, so it's going to come down here, come back here. So what this graph is going to look like, it's going to look like this for right now. So if I go 3 above 5, this would get to 8. If I go 3 below 5, this would get to 2. Okay, so I'm relabeling the x-axis. And then this 4 right here means will happen 4 times between 0 and 2 pi. So right now it's only happened once. So if you have a whole number there, the trick on this is to do this. This is going to still happen at 0. This is going to happen at pi over 8 now. Okay, so I'm multiplying by 1/4. This is going to happen at pi fourths. This is going to happen at 3 pi over 2. times 4 on the bottom. So that's going to happen at 3 pi over 8. And then if I multiply by 1/4, I get 2 pi times 1/4, which means it's going to happen at pi over 2. So that gets to pi over 2. So now my labels are correct. I show, because these iterations took place, I changed my labels on my x-axis. And so that means our graph happens between 0. It happens between 0 and pi halves rather than 0 and 2 pi. If you do it this way, you don't have to go and try and graph out 4 iterations of the graph between 0 and 2 pi. So now you're not looking at these values any longer. You just used those as a guide originally. You're realizing that this is not the x-axis anymore. The x-axis right now is down here. Okay? So that's just one way of looking at it, which should help you out. So again, the sine homework will not be due until Monday, a week from today. Okay? But I would say get a good start on the odds if you can. There certainly will be enough time to answer some questions on Thursday or Friday about sine. Again, I'm not expecting sine to be done, but what I'll do on Thursday or Friday is I will finish it up sine and then move to cosine. Again, cosine and sine are just a phase shift of 90 degrees or pi halves. And that'll make more sense when we get there. But tomorrow we will have the quiz that we just ran through. I'll post these notes, and then I have to post the page. I didn't post the page yet on Schoology, but I'll get that posted for you. As far as the sine goes, I don't think I put sine in there, but I think I have it in there last week, but I'll make sure I put it in this week. So tomorrow and Wednesday, we will do the quiz. Please bring your unit circle. If you don't have that with you, please take a picture of your unit circle, and that way you have it on your phone, and that's the only thing I'd let you use your phone for. Sound good? Questions, friends? We good? All right, I'm going to stop recording.